Water is leaking out of the base of the bluff between N Street and 10th Street. There's no question about that. The challenge is to quantify it, locate it, understand why it's happening, get people to care about it, and then try to restore it to a more natural occurring quantity. These videos are from April, when it's easy to imagine rain soaking through the soil and continuing to the base of the bluff, especially since there are much less trees and roots in the neighborhoods at the tops of the bluff than there used to be. Here is a comparison between 1990 at the top and 2016 at the bottom. Google only has aerial photos going back to 1990, but in 1980 almost this whole area west of N Street was forested. The red lines show the triangle formed by N Street and 10th Street, and the little yellow markers at the base of the bluff on the beach are locations where, in April, I saw water leaking through the bluff. With water still pouring out like this in August, however, stormwater seems harder to blame. This overhang results from the leaking water pulling out the fine particulate, leaving gravity and wave action to easily remove the gravel. Eventually, the overhang will fall to the beach. So it seems clear that the bluff leakage is accelerating bluff erosion in this area. And to have this much leakage in August, either the water is traveling a long way underground to then leak only between N Street and 10th Street, or nearby wetlands drain throughout the year into this zone, or the water leaking in the dry months is coming from watering of lawns and other plants. This is where the mountains greet the sea, and the mountains collect a lot of moisture over the fall, winter, and spring. But it doesn't seem likely that if somehow this was the mechanism for bluff leakage in August, that this zone would be the only place between the Elwha River and the base of Edda's Hook where these subterranean channels would exist. Another possibility is that nearby wetlands channel into this zone. This seems possible since there are designated wetlands less than a half-mile uphill. The green shapes in this view are designated wetlands, and the blue lines are calculated streamways from ArcGIS based on the LiDAR topography. They show the way the surface water would flow in a natural environment without catch basins and culverts. It seems possible that surface and subterranean waterways could exist that would direct water to the bluff in this area. The red lines introduced here are the city's stormwater pipes. Note the drainage system under the fields at Cheyne Park and how that water is directed into the 10th Street wetland rather than the more direct route to the bluff that would happen naturally and occurred historically. In order for water to travel from the 10th Street wetland to the bluff, it must either travel underground and not lose more than 190 feet of elevation, or entering through Gate A to the city culvert and then get poured into the 8th Street pond. The 8th Street pond is only a pond after about an inch of rainfall. In those conditions, the pond water can escape through Gate B and cascades over the bluff through the culvert at the end of N Street. A third explanation for bluff leakage is that in the relatively rainfall-free summer months, the water is coming from the watering of lawns and plants, which doesn't drain into the city stormwater system. This graph shows the monthly municipal water consumption since January 2018 in the Milwaukee Heights neighborhood just west of N Street and north of 8th Street to the bluff. The left-hand y-axis is how the data are saved by the city in monthly totals of cubic feet. The right-hand y-axis converts the cubic feet to gallons and divides by 30 to get an average daily consumption rate rather than monthly. The average wintertime use for this city block is about 3,200 gallons per day. The water consumption surges in the summer to an average of 5,500 gallons per day for July, August, and September. The shoulder months of June and October are in between. This seasonal surge in residential consumption has occurred citywide for the last 20 years, and it seems reasonable to assume that the summertime surge is due to watering of lawns and gardens. While the impermeable surfaces like roofs, streets, and driveways typically have catch basins and drain out the N Street culvert, the water used for watering enters the soil and is free to flow to the bluff. That amount is about 2,300 gallons per day for this area in July, August, and September. Interestingly enough, a curtain drain just downhill of the Milwaukee Heights corresponded fairly well to that rate when it was measured on August 1st, 2020. I tried to quantify how much water flows from the bluff at the beach level at the end of August. The leaks often drip across a bigger area than the mouth of the coffee can, but qualitatively it is easy to see that the flow on the beach at the end of August is of the same order of magnitude as the water being used for lawns and gardens. Keeping things in perspective though, Port Angeles gets about 25 inches of rain per year. If we say that no rain falls in July, August, or September, that means all the other days average 0.09 inches of rain per day. That much rain on the Milwaukee Heights neighborhood is 16,000 gallons a day, or 7 times as much as produced by lawn watering. If the impervious surfaces of the houses and driveways divert 30% of that to the stormwater system so that it doesn't enter the soil, then the rain is only 5 times as much as the lawn watering. The other neighborhoods in the vicinity of the bluff are probably similar, although uncalculated. The magenta and yellow basins are huge in comparison, and are relevant insofar as stormwater from these basins are able to reach the bluff either through subterranean channels or via the 8th Street Pond. I believe that whenever about an inch of rainfall falls in a day, Gate A becomes active and then quickly fills the pond, and then Gate B becomes active, sending any additional stormwater directly over the bluff through the in-street culvert. Here is the average daily rainfall for the Port Angeles Airport for the years 2010 to 2014. There really are not that many occurrences of greater than an inch of rainfall, and likewise, the in-street culvert is not frequently active. The 7-day running total of rain might match up better with when the gates are active, because it takes a while for them to drain. There might be a more appropriate period than 7 days, too. The next question is, to what degree is the water coming out of the bluff due to human manipulation of the natural water flow? As mentioned earlier, turning forested areas into housing developments blocks the absorption capabilities of the soil. In the summer, taking water from the Elwha River and depositing it uphill of the bluff introduces water that wouldn't be there naturally. Cheyne Park probably gets a lot of that Elwha River water, and about a third of the Yellow Basin would flow to the gully along Hill Street if it was not piped to the 10th Street wetland. Remnants of a creek are visible just west of N Street, south of 10th. It would make sense if N Street was filled between 10th and 4th, and the creek used to naturally drain this area. Of all of these, probably the biggest impact is the lack of absorption, but it is also very hard to quantify. Finally, we are left with the question of how should we change our behavior, our policies, and our regulations to bring the leakage to natural occurring levels. Don't channelize the flow. Minimize dry wells. Include a curtain drain into the plans for the improved Olympic Discovery Trail as it parallels Milwaukee Drive. This corrugated pipe with gravel on top could relieve the soil of excess moisture and deliver it to the stormwater system. Evangelize and incentivize native plants. Correlate rainfall to water height at the 10th Street wetlands and 8th Street pond, and to flow or no flow conditions at gates A and B. Test for chlorine or other traceable chemicals in drips from the bluff in the summertime. Adapt to a faster eroding bluff. The reality is there is more human impact on the bluff now than there was 40 years ago. We should do what we can to minimize that impact, but that includes giving the bluff its space. While our current policy shoots for a 75-year minimum lifespan for new structures, the regulations are not in line with that policy. And finally, and perhaps most importantly, encourage access to the beach. This beautiful beach is underappreciated and underused because 5 years ago it was a difficult, unpleasant beach to walk on. As Crown Park undergoes renovation as part of the Olympic Discovery Trail project, the trail to the beach deserves an upgrade as well. Without question, the best way to restore the bluff is to create the next generation of stewards who can make this beach one of the treasures of Port Angeles.